Good afternoon to all. I'm Dr. in Pharmaceutical Chemistry Department, Warren College of Machining. Now, this is the 7th lecture, and this lecture is definitely continuation with chromatography special. Now, these lectures will definitely help you again to solve a certain data for how it improves the efficiency, as there are certain parameters you can calculate that is so much important for the better selection of two or multiple compounds. And with this, you will know that the parameters naming, the abbreviations, as well as how they are useful for the cell needs. Okay? So we start. These are population derived quantities. Now, linear mobile phase velocity is defined as the length of a column as well as the rotation time in the mobile phase. Now, the volume of mobile phase, how you define the rotation time of the mobile phase with the F, that is the factor showing the capacities. Okay. Now, the rotation factor is the K, that is rotation factor, that is the rotation mobile phase of analyte, the rotation of the mobile phase. So, in this way, these are the formulas generated. Now, the diffusion constant is K1, capacity factor or rotation factor by Vm. Vm is a volume of a required phase. In this way, you can see that there are different type of formulations. When you are in the phase and stationary phase, you have to know how much of the mobile phase used and how much of the stationary phase. The of the stationary phase of the mobile phase, there is more of the mobile phase from one side to another till the end of the column. The mobile and the stationary phase. What is the velocity in this mobile phase with the solute? It travels the one side to the other side. What is the velocity of the phase? So these are the fundamentals. Now the resolutions. Now these are the resolutions. The resolutions, whenever we are just find out, we need for the two type of different bit isolated from each other and having a sufficient defined differences. So that differences is a genuine we have it. In the lectures we already seen what is a TRA for the one peak area and peak size, and for the TRV. No, that is rotation and analyte in the solute and rotation in the solute in the stationary and the body. So these are the width of A1 and this is the width of second one peak. This is the first. This way you can find out the resolution of it. What is the number of plates? The number of plates you identify is that was the city by TR by width square. In this way you can find how you can find the height. So the length of the column divided the number of plates is available in the phase. The retention time. Retention time is also you can this formula using the height by the retention and the retention factor capacity factor using of the selectivity factor. So this way, if you know that, you can just plot it beside the station of the column. So this using this one, you can easily identify retention time. Now, after this retention time, you realize that this required formula is definitely related to the quantity also. What is that? The retention time, then the band broadening, then height of the theoretical plate, then multiple pathways, then average linear velocity. Then also we have the height of the theoretical plate is correlated with the Gaussian curves is related to the variance. Now variance factor is dependent on the height of the theoretical plates. Selectivity factors and velocity of the mobile phase and the velocity of solute in the mobile phase. So these are the different types of very important formulas, and you have to totally understand the formulas, how the values of all formulas comes when you are developed in any chromatographical methods with the two component separations. And whenever you are done your practical, you just justify your practicals with the calculation of all these formulas, and these formulas already having their standard values. If they matching the values and significantly you define your chromatograph in a very identical way, you can easily identify with the proper resolution, selectivity factor, so very good that you have already optimized your very good chromatography. But in case there is a certain problems which is not getting your completion of chromatography and the values is not get the satisfactory result, so you need to go a dependency factor with each other. The dependency is definitely linked with each other. These all values, all the factors are linked with each other, and you have to go very step. Particularly this series of the lectures and just in such a way everyone knows the principle of every theory, but when the theory comes and when the mechanism is happening in that, and there are a lot of students, the post-graduation, they are facing the problem in that chromatography. They don't know even the calculation, they don't know your the standard values, and they are optimizing the chromatographic methods and just publish their research, but they don't know how they develop the method. What is the basic fundamentals they needed for completion of their development, and after the optimization they developed and they publish also. But whenever they saw the tip of whatever data they cover, but if they don't know is they started and don't know how to improve, how to correct it, how to get better improvement. So they are nothing. The type of research will be work for a long time. In your mind, these are very basic things and get very well. So this is how to control the capacity factor. Capacity factor is a great dependent to improve the sections. Now, in changing the temperature, capacity factor affect and change. If the capacity factor is changed, your separation may change. If your capacity factor is good, your resolution may be good. For the gas chromatography, the temperature is a dependence factor because the gas is very high temperature. But in case of composition of the mobile phase, no, it's not needed because the temperature is as affected because you don't want to pressurize the liquid to move on the mobile phase and on the stationary phase. It's composition of mobile phase selection more than chromatography selection. Okay, the capacity factor is definitely increased and it's not exactly one type. It is increasing number of theoretical plate, definitely optimized capacity factor may be close to you and the resulting separation time is very closer to you. If you want to change your capacity factor, you are increasing number of theoretical plate. So you can manually or you can manually have to change your column and with a high number of the theoretical you have to adjust it and optimize the capacity factor. Now these are significantly changed. You feel that it's very good. So on the basis of what point you keep in your mind, this is needed, changing mobile phase composition. This is the first step that to set the changing it. Because you're not changing the repetition of column because column extends you. Instead of column changing, you need to change the mobile phase. You need to change solvent where you are dissolving your substance, your solute. And temperature of the column is changed. Yeah, it may affect longer to get cut your column or get blockages with absorption with mobile phase erosion type of composition will happen in your stationary. And the composition of stationary, that is polar, that it is a non-polar, the obstacles who are moving on the stationary, what type of composition it has. Maybe a chance affinity is more if it is a long time or we are deposited from the stationary phase. The affinity covers more than mobile phase, then there is less chances to get deposited on the stationary phase. So the composition of the stationary phase is dependent. If you have selected a heavy molecular weight component, high proteins, carbohydrates, yes, there are very chances to get a deposition of the on the stationary phase. Okay. So in this way you have to just develop your fundamentals. This is used. For example, using a specific chemical effect, incorporate this with the complexes type of volume, the state, or use the yes, somehow first part or the phase to get ruptured the pores and let not get easily absorbed, not easily interacted with the different type of modes. So take care of that. Washing of the precipitation when before the start of experiment, after the experiment, the column washing is very important. If you washing good and creating, it's very better than one time is mandatory before your experiment and after your experiment. Don't leave your lab before washing your column because if that does definitely affect the deposition of it on the stationary phase. So this is the general now. Let's see the different type of 6 components. 1, 2, 3, 4, 5, 6. This is a poor resolution. Again, this is a key resolution. This resolution is good. But the immediate resolution, we don't less than or resolution. So this resolution we are expected somehow extended because this time that compound is not interacted much more good time with your stationary phase. Your solute, your component, it will interact on the stationary phase. This is a very strict relation. This is a certain resolution. If you know this is the linearity of the velocity, then multiple passes band broadening, height, then dating time, longitude. This, if you calculated on this pen, these the values defined and these are expected as per the standard. So this may be a chances कि you can consider a very well manner. So in this way, this resolution may be accepted if the value of it is the value which is close to the standard and so match to the standard. So may but these are the not expected because it is somehow a very band broaden. Instead of these are maybe this is the okay, but these are the so early. So less than the retention time 2 is not accepted. We are not accepted कि these are reacted or good time spending with stationary phase by your solute. So these are the device components in factor consideration by your mobile phase consideration and retention time consideration and the capacity factor, safety factor. So these are linkages which are and you have every point go in a deep manner and again get a trials, different trials. You can't change the column. Instead of the column, you are just watching the column names and change the parameters and change the composition of the phase. So maybe this get here more than a 2 retention time. Okay.